Hey guys, so get out your notes, 6-7, radicals and square roots. I'll give you a second to get ready. Desmos, go ahead and open up Desmos. We're going to do this together. I'm here for you, I'm here to help you. We'll figure this out. Alright, so we're going to do some looking at the graphs of our square root functions today. Of course, our square root function looks like this. F of x is equal to, and by parent function, that's the very basic version of the function without any fluff added to it. So that's just the square root of x. Of course, f of x is the same thing as y, so you can also imagine that as y is equal to the square root of x. So we have no other numbers in here, but all it has is the square root over some number, and that is the parent function. We're going to get more into comparing our functions later, but just so you have it, that's what it is. Alright, and first thing we're going to do is go ahead and look at the graph of this function. So, in Desmos, let's type this in, y equals radical x. And as you're doing these, you should be doing them with me on your own version of Desmos. Watching me do it is not going to help you remember it as well. So do it yourself along with the video. Use that pause button if I go too fast. So here we go. So we got our parent function graphed in, y equals radical x. And so this is what the general shape of any square root function will look like. Okay, it'll just be different depending on negatives and other numbers that are put in there, but this is the basis. Okay, so it starts out like this, and then we're going to look at the characteristics of this graph and kind of tie it into domain and range, because domain and range can be tricky. So we're going to practice that a lot, and there's a few others. So we're going to start with it here. So see where the base of this starts at 0, 0, and then it curves up. Now we can take points from that to kind of help us. Remember, you click the settings button. Let me go back. You click this button right here once you're in that box, and then click table. And I want to see some. Now look at this. You have some undefined. So there's nothing there. That means the graph cannot exist. Why can't the graph exist when we have negative numbers? Well, imagine negative 2 or whatever is here in place of x. What's wrong with that? You can't have a negative under the square root. Yeah, that's wrong. Okay, so that's why you get that undefined in your table. Remember, you can type in any value that you want in your x column, and you can get its corresponding y value like that. So we have these coordinates, and we'll go ahead and plot those on there. 0, 0, 1, 1. Oh, what else did we have? 2 is 1.4, so just do an approximate 1.4. Let's do a further out point. Let's do like positive 5. Okay, 2.2, so positive 5 is at 2.2. So this is curving up rather gradually. So it'll look about something like that. Okay, endpoint is, of course, like a ray. Remember, a ray has one endpoint, so that's kind of the similar idea on this. Is my endpoints right here, and of course that would be 0, 0. Okay, remember your domain is your left to right. What's the graph doing left to right? Range is down to up. Okay, so if we're going left to right, let's find the first thing on our graph, which is not an arrow. So if it's not an arrow, it's not negative infinity. But we have, what number? Yeah, 0. So I'm going to go ahead and do this in interval notation to show you, because I think most of you will like interval notation the best. So it goes from 0, and then what does the graph do? So you find the most left part of the graph, and then you keep going to the right, and then you find the ending of the graph. The ending of the graph is an arrow. That's easy, indicating that if it has an arrow, it's always going to be infinity in that direction. Or you can set this up as a set notation, like x, such that, because domain is always x's, and the range instead will be y's. So the domain, what do my x's do? They are greater than or equal to what? They are greater than or equal to 0. Yeah. So you would put this, x, greater than or equal to 0. And this means the same thing. Remember, your bracket means equal to 0, and then infinity is greater than 0. And this means the same thing, just written two different ways. Okay, now we're going to do range. So we start down, and we go up to the lowest part of our graph, which is right here. No arrow. So again, no infinity. So what number am I at? I'm at 0. And I'm equal to 0. And then what does my graph do after that? Does it continue to go up? So from down to up, yes it does. It goes from 0 to positive infinity. Now, yeah, it's mostly going this way, but it's doing both at the same time. This direction is moving right, and it's moving up at the same time. So that's two directions of infinity that it's taking. Alright, or we can set it up as, so range is my y's. Oh, I didn't have to put that again. Sorry. So y is what? Same thing. Y is greater than or equal to 0. Alright. Think of these as your limits. What's the limit of my graph? What's the limit when I go left, and what's the limit when I go right? The limit when I go left is 0. The limit when I go right is there is no limit. It goes on forever. And then same thing with up and down. Is there a limit when I go down? No. Yes, right here. And is there a limit when I go up? No. It would go on forever. So it's all in terms of this line of how you're defining these. Okay. Let's go ahead and throw cube root in there, just in case you see some examples of this. So the cube root function will be, of course, the third root. So where f of x is equal to, instead of square root, third root of x. And of course, instead of f of x in Desmos, we will put in y. Just make everything a little bit easier. So y equals third root of x. Alright, so this gives us square root. So this is where you will get third root in Desmos. You will click Functions, and Miscellaneous, and then this button right here, you can type in any number root that you desire. So when I click that, I get this, so I need a 3. And then I push the arrow, and the arrow will take me, when I'm up at the 3, I push the right-hand arrow, it takes me down here, and I can type that in. Alright, zoom out a little bit, get a better idea of what this looks like. Yeah, alright. So we've got something similar to before, but now we're going down in this quadrant, quadrant 3. It's kind of doing the same thing. It's doing a reflective move in the same way. Alright, and that is because now I'm allowed to have negative numbers. Remember, third root of a negative number is the same number but negative. Unlike the square root, you can't have a negative number. So we can do the third root of, just as an example, negative 1. That is an answer as negative 1, as opposed to if this was square root, it's impossible. Well, it's imaginary, and we'll get there eventually. But right now, just know that, yeah, third root of a negative number is that negative number. So we have negative numbers in our square root or cube root function. Let's change this to a table so we have some points to plot. So we have negative 2, negative 1.2. So negative 2, negative 1.2. Pretty sure we went through 0, 0. I'll go ahead and put that. Negative 1, negative 1. Oh, forgot that one. And 2 and 1.2. Alright, I'll just go ahead and stick with these points, as long as I got something to take me that way, and I've got something to take me that way. I'm good. Alright, turning point's a little different for this. The turning point is where, well, I'm going one slope and then I change, well, not really slope, it's like a curve. And then the curve starts to change, okay? So that's going to be this point right here in the very middle, and that's 0, 0. Alright, your domain is left and right. So starting from my left, the left of my graph is doing what? Here's a clue. Negative infinity. Yeah. And then when I go this way, left to right, I have another arrow. So domain on this one is all, or you can just put the all real numbers. That's the same thing. Infinity to infinity or all real numbers. The range, going down, yep. And going up, yep. So down and up are both good as well, so the range is the same. Okay, this next little section we're going to skip. I'm going to do all the transformation stuff of graphs together later on when we do our graphing unit. So, yes, we're doing a little bit of graphing as we go because it helps us with different things that we have to know for some of these. It gets us a base idea of what we're learning. So we're going to skip transformations. Again, this is transformations, so we'll skip through this. I want to go to this part, the graphing of radical functions. Alright, so we're going to practice doing some of these, identifying the characteristics that happen. So graph the radical function and then identify the key characteristics. Which here we're going to do endpoint or turning point, and then the end behavior, that's something new, and then this right here is new. So these are new, so really pay attention to these, okay, which we're about to get to. Let's go ahead and graph this in Desmos. So we have radical of x plus 5. Okay, so that 5 is not under the square root, so I need to put an arrow going out from under that radical and doing this. So here we go. So I need some points. It gives me 0, 5. Oh, yes, there we go. You can also do this. Drag along here and see what kind of points we got. Oh yeah, cool. Forgot about that. Let's do 0, 5, and 8. 7.8. 0, 5. As long as you got 2 points, that's alright. 1, 2, 3, 4, 5. 0, 5, and 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And it was a little bit under 8, so about right there. And then I know the general shape. So I'm just going to go ahead and draw it. So if you know the general shape, just plot kind of an endpoint and then another point in that direction. So you have a basis of what it should look like. Okay. Alright, now let's fill these in. So domain, left and right. Yeah, we are stopped at 0. So we need to say that, I'm just going to do set notation way. X is greater than or equal to 0. And of course you can do it this way, bracket 0 to positive infinity. I have a feeling you guys will probably like this one better. So I'm gonna do that one. Now my range, my lowest point on my y is right here. I don't have any values below this. So what value is this for my y's? So I base that on the y-axis and it's 5. So I'm equal to 5, but it increases after that, so it's everything above 5 as well. So infinity. Alright, endpoint is, of course, at 0, 5. We already established that. Alright, end behavior. What this means is what is the graph doing as it goes in either of these directions. So I know that my x's are doing what? They're approaching 0 and they're approaching infinity. So the best thing you can do is take these two values and put them here. Okay? Let me do that in a new color. So you're going to take that value and put that there. And then you're going to take this value and put it here. So as x approaches 0, we're going to say what this does, and then as x approaches infinity, what does it do? So end behavior is the end of the graph. That's all it's saying. It's asking for. All right, now we have the f of x. Of course, f of x is really what? Yeah, that's y. Okay. So basically, if my x's are doing this, what are my y's doing? As x, and what the arrow means is approaches. X approaches. Just some vocabulary here for our symbol. As x approaches 0, so what I want to do is pick a place in the middle and then go that direction. As all my x values, so this is x is like 5, 4, 3, 2, 1, 0. As x approaches 0, what are my y's doing? And what we're looking for is where is it going? Okay. So as x is going to 0, my y is going to what? Yeah, 5. It's like decreasing down to 5. So we're going to put 5. And then that decreasing part, we're going to get to that down here. As x is going positive, so to a positive infinity, so that would be this direction. As x is going this way, what are my y's doing? My y's are continuing to increase, which we'll put that there in a second, but they are also going to infinity. So here, we're going to put infinity. In other words, x and y are going into infinity together. That's what we're saying. And then in this, x is going to 0, while all my y's are decreasing to 5. And you can see it's matching this right here for my end behavior. Now the increasing interval, what we have to imagine on this is slope. So increasing, decreasing, we are identifying the slope. Okay? Remember that this is a positive slope, and anything doing this is a negative slope. So we're comparing it to that, okay? All right, so am I increasing slope on my graph or decreasing slope? It could have both. It could have only one, or it could, well, probably not have neither, unless it's a vertical or horizontal line. All right, so this kind of slope is a what? What's happening? Is that more like positive or negative? Yeah, it is definitely positive slope, okay? So this is similar to linear, but we have just a curve in our graph. So as I'm going from the left, as I'm moving from the left to the right, I'm increasing. If it was the other way, it would be a decreasing interval. So I have no decreasing interval, or none, in this particular case, but I'm increasing the entire time. So all you have to do is say I'm increasing from my x values. What x values? From 0 to positive infinity. Alright, so the slope of, and let me add that on there, it would be helpful. Slope of x's. So we're just saying what the slope of the x's is. So a lot of times it'll be, like in this case, it happens to be the same as the domain. And because the domain is the x's, so it makes sense. Okay, ready to try another one? Yeah, let's do one like number, let's do one maybe a little bit different. Maybe 8? No, not 8, 9. I'm looking at my paper and I said the wrong number. Alright, let's do number 9. Let's, so we got a number out here, 3 radical x plus 1. Three radical x plus 1. Yes. Okay, we're good. So, adjust my graph so I can see everything. Alright. This time my endpoint is -1, 0. And 0, so I'm intersecting x-axis at -1 and then positive 3. So, those are two important points. So, -1 and positive 3. So that's a good idea, especially if it crosses both of your axes. Go ahead and make both of those intersections. I should have done another point. Oh, let's back up. Let's look for another point. Maybe about 6, 8. Really close to that. So just so that way I have 1, 2, 3, 4, 5, 6, 7, 8. Whoa. Yeah, I was a little bit off. So that way my graph is more accurate. The more points, the more accurate the graph will be. Okay. Alright, so let's go ahead and label domain and range. So domain. And you can also do these thinking of as your starting points the middle. You can think of it either way, as you're starting from the left and you hit the graph and no arrow means it's at that number, or you can start at the middle and say, oh, it goes to what on this side, and then it goes to what on this side. So on this side, it goes to my domain is x's. My x's, which I'm looking at this line, are at all the way to -1. So I know I'm at -1, but I don't go past that, no arrow. But the other way, I go to positive infinity because I have an arrow. All right, range is down and up. So down, I'm going to what number? On the range, which is the y's, I'm going to 0. And then when I go the other way, when I go up, I got an arrow, so that's infinity. All right, our endpoint is -1, 0. We already used that to graph. Then we take the two numbers that were from our domain, and we're going to put them right here. Okay, -1, infinity. So this means approaches, again, as x approaches -1. What are my y's doing? So this is what it's asking. What are the y's? They are approaching 0. Yes. And then as x approaches positive infinity, all of my y's are, so on my y-axis, they are also going to infinity. See? That's not so bad. And if you notice, we're taking like these first two and pairing them up, and these two and pairing them up. Oh my gosh, is that the same thing as what happened on the other one? Oh, it just makes everything so much easier, right? We're pairing our x's up and then pairing our y's up, and that's how we get our end behavior. So easy. Yeah, nice, especially when the numbers stay the same. All right, now, on this graph, are we increasing or decreasing? And this is, again, slope. Okay, what kind of slope we got? We got definitely a positive slope. So we will not have any decreasing interval. The entire graph is increasing from, and all you have to do is steal this from the domain and say it's increasing from -1 to infinity. Okay, but it's important to understand what these words mean. Intervals, what these symbols mean, x, y, domain ranges, x and y, you know, all this stuff. So the terminology is really what I'm trying to get you guys used to, especially being upper level math students. You are going to have to know that kind of stuff. Let's go ahead and look at a third root problem, and then you should be okay after that to try some on your own. So let's go ahead and do one like 11. Let's start with 11. All right, so radical, oops, I'm going to Desmos. Forgot what I was doing. Alright, f of x, so y is equal to the third root of x plus 3. Alright, so I'm going to have to change my root out. So remember, you go to function and this button. Okay, on the handheld calculator, your third roots are under math. Let me double check. Yeah, so under push math, and then you'll see it number 4. Just a reminder. Alright, so third root of x plus 3, and then the next part is outside, so arrow plus 2. Third root of x plus 3 plus 2. So we have the graph that continues and is like symmetrical. Yeah, geometry word. So it's symmetrical about this point. So right here is my turning point. Let's see if I can find what that is. Looks like it's, yeah, negative 3, 2. Go ahead and write that down. Turning point is negative 3 and 2. That's kind of like the center of my graph. Get a few other points on there. 0 and 3.4. So about the middle of 3 and 4. Then I intersect at negative 11, 0. I wonder if I can get out to negative 1, 2. Alright, it's out here. Alright, let's get me a couple other points. Ooh, I'm messing myself up. Negative 5 and 0.7. Let's just get one. Alright, this was my turning point, so I know I go like this, and then this one goes like this. So something approximately like that. Alright, domain and range. Do I have any restrictions as I go left or right for my domain? No, I got arrows going both ways. Yay! So that's definitely negative infinity to positive infinity. Range is up and down. Yeah, I'm going forever down this way and forever up this way. So negative infinity to positive infinity. Or you can put, of course, all real numbers. It's the same thing. All real numbers. Alright, in behavior, we take these and say, alright, just copy these in here, negative infinity and positive infinity. As x is going negative, so that would be to the left. What are my y's doing? They are also going to negative infinity. Or again, we pair up our two x values. X, 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 positive infinity would of course pair up with positive infinity. Okay, now here is where, well, no, we're not going to be changes. I was thinking we were going to have some changes, but we don't. So my slope is what all the way through? Positive or negative? Yeah, I was thinking there was negative in this one, but there's not. I'm thinking of something else. They are all positive. So as I'm going from here, my slope is continuing to go this way. Sometimes, like, well, if it was like a parabola, there would be a change. We'd have a decreasing slope and an increasing slope, both. But this is still increasing the entire way. So we're going to put negative infinity to positive infinity. The entire graph is an increasing slope. Alright, and we have no decreasing intervals. Okay? Alright, there is nothing else really weird on the rest of these examples, so that is all I have to really show you for new stuff. So why don't you try these out, and then pause the video, and when you're ready to see solutions, press play. Alright, so here we go, wrapping up these answers so you can check. Number 8, here is your information for the solutions. Nothing too strange there. Pause the video if you need to. Alright, number 10. I went ahead and graphed it, showing you that this is a little bit different as far as the interval part. So we're going, domain is from 2 to infinity. Range is starting down low at negative infinity, but it goes only up to 3. So negative infinity up to 3, and then it does not go up at all. So my turning point or end point is 2, 3 right here. The end behavior, as x is approaching 2, the y's are approaching 3. So this is a little different, as in we're not pairing up the 2 and the negative infinity. Okay, and again, that's why I wanted to show these as far as if you're coming from the middle, as x is going to 2. So if you're starting from the middle, as x is going to 2, which would be this way, the y's are moving up to this height of 3. Okay, When you go this way, as the x's are going to positive infinity, so this way is always positive infinity for x's, the y's are going continually down. So they're continuing to go down as the x's go right. And then the interval ended up being, this is a negative slope line, okay? As we're going, starting up high and going down low from left to right, that's indicating a negative slope. So we end up actually decreasing from our our x values. Remember, these are always our x values, so we just take this and put it as our decreasing interval. No increasing. And then number 12. So number 12, I went ahead and graphed it here in Desmos. I'll show you real quick just to show you. This is my purple graph. Looks like that. So it's all real numbers. The turning point 0, 0. As x is going positive, y is going negative. So positive would be this way. As the x's are going positive, the y's are going negative. And then it's the opposite. As the x's are going negative, so this way is your negative x's, your y's are doing what? They are going up, increasing. Yes, so we're doing two things at once, our side to side and our up and down. So that graph, same idea. We're starting up high from left to right and going down low, so that's a negative slope. Downhill. The skier would be going downhill skiing, so he's decreasing for his slope. So you can just put negative infinity to positive infinity as he's decreasing the whole way. Alright, and then I have also graph number 13. So nice thing on Desmos, I got this one graphed, but I got this one ready to go. So I'm going to uncheck that one and it disappears, and check that one and it appears. And so there's that one. And here are your solutions for that one. That one's all increasing. So that is it. Pause the video if you need to need time to read this, and that's it for today. So we have one more lesson in Unit 6.